Picture this: scattered across the vast expanse of space lie millions of mysterious, rocky travelers, each carrying secrets older than our planet itself. These celestial wanderers, known as asteroids, are like cosmic treasure chests, brimming with clues that could rewrite what we thought we knew about the universe. Some hold ingredients essential to life, others hide fragments of stars that existed before our solar system was even born, and a few have revealed surprises so strange they've left scientists utterly baffled. But what makes these space rocks so captivating is not just what they contain, it's what they represent. They are remnants of the early days of our solar system, frozen in time, and studying them is like flipping through the first pages of the universe's diary. Stay with us as we delve into 25 of the most bizarre and mind-bending discoveries ever made on asteroids, from traces of water to hints of alien metals, and even peculiar signals that defy explanation. Each revelation pushes the boundaries of what we believed was possible. This is a journey into the unknown, where every discovery brings us one step closer to unraveling the mysteries of the cosmos. Are you ready to unlock the secrets hidden in these celestial time capsules? Let's dive in. Now turning to one of the most profound discoveries in asteroid research, scientists have found undeniable evidence of water molecules on these rocky wanderers. This groundbreaking revelation has sparked a cascade of questions about the origins of water on Earth and, by extension, the very foundations of life itself. The discovery was first made possible through the use of advanced tools called spectrometers, which allowed scientists to analyze the composition of light reflected off asteroid surfaces. When these instruments detected the telltale spectral signature of water molecules, the implications were staggering. Could it be that asteroids played a key role in delivering water to our planet billions of years ago? Some researchers believe these celestial bodies acted as cosmic couriers during the chaotic early days of the solar system, colliding with Earth and depositing the precious liquid that would eventually give rise to oceans and ultimately life. However, the origins of these water molecules continue to fuel debate. Are they remnants of ancient ice that formed in the frigid outer reaches of the solar system, or could they have been created through chemical reactions driven by solar radiation on the asteroid's surface? While scientists grapple with these questions, one thing is certain: this discovery has expanded our understanding of how vital resources might exist and be transported across the cosmos. And with every passing mission, including breakthroughs from spacecraft like Hayabusa 2 and OSIRIS-REx, we edge closer to unraveling this mystery. The presence of water on asteroids not only deepens our understanding of our own planet's history, but also fuels hopes of finding life or its precursors elsewhere in the universe. Moving forward, this discovery raises a tantalizing possibility. If water can be found on these ancient travelers, could the building blocks of life be hiding there too? Now turning to another remarkable revelation, the detection of organic compounds within asteroid material has revolutionized our perspective on the origins of life. These compounds, which include crucial ingredients like amino acids, are the fundamental building blocks needed to form proteins and ultimately life as we know it. The discovery of such life-essential molecules embedded in these ancient space rocks suggests a tantalizing possibility that asteroids could have played a pivotal role in seeding the early Earth with the components necessary for life to emerge. Imagine these rocky travelers as cosmic delivery vehicles, carrying a precious payload that might have jump-started the complex biological processes on our planet billions of years ago. Missions like Hayabusa 2, which visited the asteroid Ryugu, and OSIRIS-REx, which studied Bennu, have provided groundbreaking evidence to support this theory. These spacecraft not only observed their target asteroids from afar, but also collected actual samples from their surfaces, These pristine samples revealed a treasure trove of organic molecules preserved within the asteroid's material for billions of years, waiting to tell their story. What makes these findings even more astounding is their implications for the universality of life's building blocks. If organic compounds can form and persist on asteroids drifting through space, it raises the question of whether similar processes could occur elsewhere in the cosmos, potentially leading to life on other worlds. As scientists delve deeper into these discoveries, debates continue to unfold about whether life's precursors originated exclusively on Earth or were delivered from space. Either way, these compounds provide crucial clues to understanding not just our past, but also our place in the vast, interconnected story of the universe. As the exploration of asteroids continues, so does the quest to uncover more secrets locked within these ancient time capsules. Could these tiny molecules hold the answers to one of humanity's most profound questions? Moving forward, let us uncover a dazzlingly unexpected find: microscopic diamonds tucked within the material of asteroids. Yes, you heard that right, diamonds, albeit tiny ones, hiding in the ancient rubble of these space rocks. But how did these sparkling gems come to be in such an unlikely environment? Scientists believe that these diamonds were forged under intense pressure, created during catastrophic collisions in the depths of space. Imagine two massive celestial bodies colliding with unimaginable force, the resulting shock waves compressing carbon into diamond form. These tiny diamonds are not merely a spectacle, they are time capsules. By examining them, researchers can gain crucial insights into the violent histories of the asteroids they inhabit, revealing details about the conditions and processes that shaped our solar system billions of years ago. What is even more fascinating is that some of these diamonds contain inclusions, tiny particles trapped inside, that provide an extraordinary window into the interiors of planets and protoplanets that existed long before our Earth took its current form. In fact, a specific study of diamonds found in the asteroid Almahata-Sitta suggests that they might have originated from a vanished protoplanet, offering us a glimpse of worlds that no longer exist. These microscopic gems are more than just remnants of cosmic collisions. They serve as a reminder of how the universe's most extraordinary stories are often written in its tiniest details. Could it be that these minute diamonds hold answers to grand questions about the forces and events that shape the solar system? As we unravel their mysteries, it becomes clear that even the smallest discoveries can shine a brilliant light on the vast and dynamic history of our universe. Now turning to another astonishing revelation, let us explore the discovery of stardust particles found within asteroids, particles that are older than our very own sun. Imagine this: tiny grains of material that predate the birth of our solar system, encapsulated within these ancient space rocks. These particles, often referred to as pre-solar grains, are remnants from a time when the universe was still young, billions of years ago. They formed in the fiery hearts of dying stars and were scattered across the cosmos in colossal stellar explosions known as supernova. Over time, these grains became part of the cosmic dust clouds that eventually coalesced to form stars, planets, and even asteroids. What makes these grains so extraordinary is the wealth of information they carry. By analyzing their composition, scientists can unlock secrets about the stars and environments that existed long before our solar system came into being. Each grain is like a tiny postcard from an ancient star, offering a glimpse into the processes that created the building blocks of everything we see today. These stardust particles have also been found to contain isotopes, variations of chemical elements that are not naturally produced in our solar system. This provides compelling evidence of their origins in distant stellar nurseries. Furthermore, studying these grains helps researchers piece together the puzzle of how the raw materials needed for planets and life were dispersed across the universe. The fact that these ancient grains have traveled for billions of years, survived the chaotic formation of our solar system, and ended up embedded in asteroids is nothing short of miraculous. They serve as tangible links to a time before time as we know it, reminding us of the vast and interconnected history of the cosmos. Could these tiny grains hold the answers to some of the most profound questions about our origins and the evolution of the universe? As scientists continue to analyze these ancient relics, one thing becomes clear: the story of our solar system begins with the dust of distant stars. Moving forward, let us delve into the remarkable discovery of alien metals found on asteroids, such as iridium and palladium, elements that are considered rare on Earth yet exist in astonishing abundance on these space rocks. These metals are especially intriguing because they are not only valuable but also hold clues about the formation and composition of our solar system. Iridium, for instance, is often associated with extraterrestrial impacts on Earth, including the asteroid that is believed to have caused the extinction of the dinosaurs. Its presence in asteroids suggests these celestial bodies may act as reservoirs of materials that are scarce on our planet. Palladium, on the other hand, is a highly sought-after metal on Earth, used extensively in industries like electronics and renewable energy. The sheer quantity of these materials on asteroids has sparked significant interest in asteroid mining, a concept that once seemed like science fiction but is now being seriously explored by scientists and private companies alike. Imagine the potential of harvesting these metals from space, where their abundance could revolutionize industries and even reshape global economies. This discovery has led to discussions about the feasibility of new technologies capable of extracting and transporting these materials back to Earth. Moreover, the study of these alien metals helps scientists understand the processes that occurred during the early days of our solar system, when heavy elements were distributed among planetary bodies through massive collisions and cosmic explosions. By analyzing these metals, researchers gain insights into the violent and dynamic history of asteroid formation. As we continue to investigate these metallic treasures, the idea of asteroids as both scientific gold mines and potential sources of unimaginable economic value becomes ever more tantalizing. Could the future of resource acquisition lie not on Earth but among the countless asteroids orbiting our Sun? With this possibility in mind, the study of alien metals offers a glimpse into a horizon where space exploration and industry collide in groundbreaking ways, setting the stage for new opportunities and challenges alike. Now turning to the fascinating discovery of magnetic fields around certain asteroids, scientists have uncovered evidence that challenges long-held assumptions about these celestial bodies. Typically, asteroids are considered far too small to sustain magnetic fields, as they lack the internal dynamo mechanisms found in larger planets like Earth. Yet, traces of magnetism have been detected on some asteroids, leaving researchers both intrigued and puzzled. This surprising phenomenon suggests that these space rocks may have undergone complex processes in their past, possibly forming from larger parent bodies that once had active magnetic cores. As these parent bodies fragmented through massive collisions, pieces of their magnetized material could have been retained in the resulting asteroids. The study of these magnetic fields offers a valuable window into the history of asteroid formation, shedding light on how materials were distributed and organized in the early solar system. Additionally, understanding this anomaly could provide clues about the internal structure and composition of asteroids, offering deeper insights into their origins. Magnetic fields might even affect the way certain asteroids interact with their environment, influencing particle movement or solar radiation patterns in their vicinity. These unexpected findings remind us just how much remains unknown about the dynamics of space. What secrets might these magnetic anomalies still reveal about the universe? As we continue to explore the enigma of asteroid magnetic fields, this discovery opens up new questions about the nature of these small but powerful remnants of the solar system's formation. Moving forward, let us examine the intriguing possibility of hollow asteroids, a concept that challenges traditional views of these celestial objects. Take, for instance, the asteroid 16 Psyche, a body that has captured the attention of scientists due to its unusual characteristics. Some researchers propose that this asteroid might contain large hollow spaces within its structure, a theory that opens up fascinating questions about its origin and formation. One hypothesis suggests that hollow asteroids could result from cataclysmic collisions in the distant past. These violent impacts might have stripped away substantial portions of their original material, leaving behind a shell-like structure or pockets of emptiness. Another possibility is that certain asteroids could have formed with a porous, sponge-like composition, with voids naturally incorporated during their creation. Exploring these hollow features could provide a wealth of information about the processes that shaped the early solar system. If such spaces are confirmed, they might hold clues about the density, strength, and overall stability of asteroids, which is valuable knowledge for future exploration or mining endeavors. Moreover, the study of hollow asteroids might even reveal unexpected insights into the distribution of materials in space, or help refine our understanding of how these celestial bodies evolved over billions of years. While we are only beginning to scratch the surface of this mystery, the idea of caverns and voids hiding within these silent travelers of the cosmos is as thought-provoking as it is mysterious. What might these hidden chambers reveal about the secrets of the solar system's past? Now turning to the mysterious cavities and craters scattered across the surfaces of asteroids, these peculiar features have left scientists both puzzled and intrigued. Take, for instance, the asteroid Eros, which is marked by an enormous crater known as Hymros. This massive depression covers a significant portion of the asteroid and raises questions about the forces that created it. Was it the result of a single catastrophic impact, or did it form through a series of smaller collisions over time? Similarly, asteroid Vesta showcases massive craters, such as the Resilvia Basin at its southern pole. This colossal feature is so vast that it measures nearly the size of the asteroid itself, leaving researchers to wonder how an object of Vesta's size survived such a destructive event. These strange craters and cavities challenge our understanding of asteroid impacts, as the mechanics of how such features are formed on low-gravity bodies remain a topic of intense study. Unlike Earth or larger planets, where impacts lead to predictable patterns of cratering and material displacement, asteroids introduce an entirely new set of variables. Their irregular shapes, low gravity, and diverse compositions mean that impacts can sometimes leave behind features that defy expectations. Some craters even appear to exhibit erosion-like processes, a phenomenon especially perplexing given the lack of atmosphere or weather on asteroids. Could these patterns be the result of electrostatic forces, micrometeorite bombardments, or some other unknown mechanism? Scientists are driven to study these anomalies not only to understand the history of these individual asteroids, but also to refine our broader theories about the behavior and evolution of small bodies throughout the solar system. These craters and cavities act like cosmic fingerprints, each one offering a glimpse into the tumultuous past these space rocks have endured. As researchers continue to analyze these enigmatic features, they inch closer to unraveling the profound mysteries of how asteroids have been shaped by their chaotic journeys through space. Moving forward, let's dive into the strange shapes of asteroids that have left scientists scratching their heads. One of the most famous examples is Oumuamua, a peculiar object that zipped through our solar system in recent years. Its elongated, cigar-like shape is unlike anything astronomers had ever seen before, sparking debates about its origin and even prompting some speculation about alien technology. While most experts lean toward natural explanations, such as it being a fragment from a larger body broken apart by a collision, its unique structure remains a cosmic enigma. And then there's 1999 KW4, a binary asteroid system where the primary asteroid is shaped like a spinning top and has a smaller companion orbiting it. This double-lobed structure raises questions about how such formations occur. Could the spinning top shape be a result of high rotation speeds forcing material outward, or is it the product of past collisions reshaping the asteroid over time? These unusual forms challenge our understanding of how gravity, rotation, and external forces sculpt celestial bodies. Unlike the spherical shapes of planets, asteroids seem to follow no consistent pattern, resulting in bizarre and unpredictable forms. Understanding these shapes is more than just a curiosity. It provides clues about the conditions under which these bodies formed and evolved. Did these shapes form early in the history of the solar system, or did they emerge over billions of years through numerous collisions and gravitational interactions? Each oddly shaped asteroid carries its own story, waiting to be unraveled, and as scientists refine their tools and techniques, they edge closer to uncovering the secrets hidden in these cosmic oddities. Now turning to the fascinating evidence of past volcanic activity, let's explore how some asteroids like Vesta have completely defied expectations. Unlike the cold and barren rocks we typically imagine floating through space, Vesta has shown signs of once harboring molten processes, a feature we usually associate with much larger planetary bodies. Scientists were stunned to discover traces of basaltic rock on Vesta's surface rock that only forms through volcanic activity. This suggests that, at some point in its history, Vesta had enough internal heat to melt its material, allowing magma to flow and solidify, forming its unique geological landscape. But how could a relatively small asteroid like Vesta generate such heat? One theory points to the presence of radioactive elements in its interior during the early days of the solar system, which could have created the necessary heat for volcanic activity. Alternatively, collisions with other celestial bodies may have provided the energy needed to initiate these molten processes. What makes this discovery so groundbreaking is how it challenges the traditional view of asteroids as lifeless, unchanging relics of the solar system's formation. Instead, Vesta's volcanic past hints at a much more dynamic history, suggesting that even these small bodies may have undergone periods of dramatic geological evolution. This finding also raises questions about whether other asteroids might have experienced similar processes, potentially making volcanic activity a more common feature of small celestial bodies than previously thought. As scientists continue to study Vesta and refine their models, they uncover new pieces of the puzzle, reshaping our understanding of how asteroids form and evolve over time. Could there be other asteroids out there with hidden volcanic secrets beneath their surfaces? It is a mystery that continues to ignite curiosity and drive further exploration. Moving forward, let's dive into the intriguing phenomenon of asteroids with moons, a feature that seems more fitting for planets than these small rocky bodies. One of the most fascinating examples is the asteroid Ida, which boasts its very own moon, Dactyl. This discovery, made by the Galileo spacecraft in the 1990s, left scientists puzzled. Ida measures about 30 kilometers across while Dactyl is just over 1 kilometer wide, yet this tiny satellite orbits its parent asteroid in a stable trajectory. How could such a small body like Ida manage to capture and retain a moon of its own? One theory suggests that Dactyl might have formed alongside Ida from the same parent body, breaking apart during or after a collision. Another possibility is that gravitational forces during a past encounter with a third celestial body may have pulled Dactyl into orbit around Ida. What makes this phenomenon so challenging to explain is that asteroids, with their limited gravity, would struggle to hold onto a moon without some external help. Adding to the mystery is the fact that Ida and Dactyl are not unique. Astronomers have discovered many other asteroids with their own moons, raising questions about how common this could be throughout our solar system. These asteroid moon systems offer scientists valuable insights into the processes of asteroid formation and evolution, as well as the dynamics of small body interactions in space. The more we study them, the more we uncover about the complex and chaotic history of our solar system. Could these moons provide clues about the collisions and gravitational forces that shaped the early solar system? It is a question that continues to intrigue researchers, keeping their eyes trained on the skies for more surprises. Now turning to one of the most astonishing revelations in recent years, let's explore the discovery of rings around certain asteroids, an attribute we typically associate with massive planets like Saturn or Jupiter, not small, rocky bodies. The asteroid Chariklo, located in the outer reaches of our solar system, shocked scientists when it was found to have not one but two distinct rings encircling it. This groundbreaking observation was made in 2014 by astronomers who noticed the dimming of starlight as Chariklo passed in front of a distant star, a phenomenon known as stellar occultation. As data poured in, it revealed the presence of these narrow rings, each composed of ice particles surrounding this asteroid, which measures only about 250 kilometers in diameter. What makes this discovery so extraordinary is the mystery of how these rings could have formed and remained stable around such a relatively small object. Some scientists theorize that the rings might have been created by a collision with another celestial body, ejecting debris that later coalesced into the distinct bands we see today. Others suggest that gravitational interactions with a yet undetected moon of Chariklo could play a role in maintaining the structure and placement of the rings. These rings have challenged what we thought we knew about the capabilities of small bodies in space, forcing researchers to reconsider the processes that shape and govern these miniature worlds. Adding to the intrigue, Chariklo is not alone. Another asteroid, Haumea, has also been found to possess a ring system, suggesting this might be a more widespread phenomenon than initially believed. These surprising discoveries continue to expand our understanding of the diversity and complexity of our solar system, leaving us to wonder what other unexpected features might be lurking among the countless asteroids that remain unexplored. Now turning to another puzzling feature of these celestial wanderers, let's dive into the strange surface patterns and markings that scientists have observed on certain asteroids. One of the most fascinating examples is the asteroid Phobos, a moon of Mars, which displays a network of long, parallel grooves etched into its surface. These grooves, stretching for miles, have baffled scientists for decades. Initially, some researchers speculated that they were the result of ancient asteroid impacts, with debris from such collisions carving out the striking lines as it spread across the surface. However, this theory has faced challenges, as many of the grooves appear to be too evenly spaced and oriented to be purely random. Another intriguing hypothesis is that the grooves may have formed as a result of stress fractures caused by the gravitational pull of Mars. As Phobos slowly spirals closer to the red planet over time, tidal forces could create these stress-induced patterns, essentially pulling and cracking the asteroid's surface. Adding yet another layer to the mystery, some scientists wonder whether these grooves might be remnants of an ancient collision event that caused fragments of Phobos to scatter and later re-impact, leaving behind these unusual marks. Beyond Phobos, other asteroids such as Eros and Vesta also exhibit perplexing surface features, including enigmatic ridges and crater chains that seem to defy traditional explanations for asteroid geology. These patterns continue to provoke debates among researchers, raising questions about the processes shaping asteroid surfaces and whether entirely unknown mechanisms might be at play. As we study these strange markings, they not only deepen our curiosity, but also serve as a reminder of how much there is yet to uncover in the ever-enigmatic realm of space. As the next challenge unfolds, let us explore the astonishing discovery of fireball activity on asteroids, a phenomenon that has left scientists both intrigued and mystified. Evidence of these fireballs has been detected through observations of sudden bright flashes or bursts of light emanating from asteroid surfaces, creating a spectacle that often evokes comparisons to fireworks in space. One prominent theory suggests that these fiery bursts might result from past asteroid collisions, where tiny fragments or dust particles left behind on the surface ignite upon interacting with solar radiation or other environmental factors. These collisions could have created shock waves or heat pockets, triggering localized explosions that release bursts of energy visible as fireballs. However, not all fireball activity can be so easily explained. In some cases, the flashes appear to follow patterns or cycles, raising the possibility of unknown mechanisms at work. Some researchers speculate that volatile materials like trapped gases or ice within the asteroid could be reacting unpredictably under the extreme conditions of space, such as variations in temperature or pressure. When these materials expand or escape violently, they might produce the brilliant bursts observed from Earth. Furthermore, there is speculation that certain asteroids might possess hidden chemical reactions taking place beneath their crusts, offering a tantalizing glimpse into processes we have yet to fully understand. While scientists continue to debate the exact origins of these fireballs, each discovery adds to the growing list of mysteries surrounding asteroids, pushing our understanding of these celestial bodies to new limits. These dazzling lights remind us that space is not a static void but a dynamic and often unpredictable theater of cosmic activity. Moving forward, we will uncover more peculiar traits, delving next into the world of rare and unusual minerals found on the surface of these enigmatic space rocks. Now turning to the next extraordinary finding, unusual minerals on asteroids have captured the imagination of scientists around the globe. These are not just any ordinary minerals but substances that have no known counterpart on Earth, making them truly alien in nature. Such minerals form under unique conditions that cannot be replicated on our planet, often involving extreme temperatures, pressures, and chemical environments only found in the vast expanse of space. For instance, scientists have identified minerals that are believed to crystallize in the microgravity of space or during the aftermath of intense asteroid collisions. These collisions generate forces so powerful that they alter the molecular structure of elements, creating compounds entirely foreign to Earth's geology. What makes these discoveries even more fascinating is their potential to unlock secrets about the early solar system. These minerals act as chemical time capsules, preserving clues about the environments and processes present during the formation of planets and other celestial bodies billions of years ago. By studying their composition and structure, researchers can piece together the story of how elements like carbon, silicon, and iron interacted in space to give rise to planetary systems. One intriguing example is a rare form of diamond-like carbon found on some space rocks, which suggests that asteroids may have been subjected to unimaginable pressures during their formation. These minerals also raise questions about the possibility of resources beyond Earth, sparking discussions about their potential use in future technologies or even interplanetary colonization. The uniqueness of these substances is a stark reminder of just how unfamiliar space is to us, offering tantalizing hints of the untapped knowledge hidden within these rocky travelers. As we unravel the mysteries of these alien minerals, new questions emerge, keeping the pursuit of understanding asteroids as thrilling as ever. With the next phase of the journey in sight, we will now explore the fascinating evidence of hydrogen and oxygen reservoirs hidden within these enigmatic celestial bodies. With the next phase of the journey in sight, we dive into the fascinating discovery of hydrogen and oxygen reservoirs on asteroid surfaces. These elements, essential for life as we know it, have been found in the form of ice, bound within minerals, or trapped in tiny pockets beneath the surface of these space rocks. Scientists believe that such reservoirs could hold the key to supporting future space exploration missions. Imagine a scenario where water, composed of hydrogen and oxygen, can be extracted from asteroids to sustain astronauts on long space journeys or even provide a steady supply of drinking water for potential off-Earth colonies. More intriguingly, this water could be broken down into its fundamental components, hydrogen and oxygen, through a process called electrolysis. Hydrogen, as a key ingredient in rocket fuel, could enable spacecraft to refuel in space, making interplanetary travel far more feasible and cost-effective. Similarly, oxygen could be used for life support systems, allowing humans to breathe in otherwise hostile environments. The discovery of these reservoirs has also sparked questions about the role of asteroids in delivering water to Earth billions of years ago. Some theories suggest that during the early days of our planet, water-rich asteroids collided with Earth, contributing to the formation of its oceans. By studying these trapped elements, scientists are not only uncovering clues about our planet's history, but also laying the groundwork for humanity's future among the stars. These hydrogen and oxygen reserves represent both a scientific treasure trove and a practical resource, bridging our understanding of the past with the possibilities of a cosmic future. As we continue, let's shift our focus to a mystery that has long puzzled researchers: evidence of impacts with unknown objects, hinting at intriguing encounters in the depths of space. As the next challenge unfolds, we delve into the enigmatic evidence of impacts with unknown objects on asteroids. These surface markings have left scientists both amazed and puzzled, as they suggest collisions with entities that defy easy identification. Unlike the typical craters formed by known asteroid or meteorite impacts, some of these markings exhibit unusual patterns, shapes, or distributions that hint at interactions with something far more mysterious. One particularly compelling example is the asteroid Tautotes, whose oddly asymmetrical surface features suggest it may have collided with an object that was neither an asteroid nor a comet. These findings raise significant questions about the variety of materials and forces at play in our solar system. Could these unidentified colliders be remnants of ancient planetary fragments, rogue space debris, or even objects from beyond our solar neighborhood? Some researchers hypothesize that certain impacts might involve dense, compact, or highly magnetic objects that behave differently upon collision, creating atypical markings. Others entertain more speculative ideas, wondering whether these encounters reveal phenomena yet to be understood, such as dark matter interactions or objects composed of unknown materials. These mysterious scars not only deepen our curiosity about what might be lurking in the vastness of space, but also provide invaluable data about the dynamics of these collisions. By studying the energy and forces involved, scientists can refine their models of how asteroids evolve over time and how cosmic collisions shape the solar system. As we unravel these cosmic mysteries, we pivot to another fascinating phenomenon: asteroids that mimic comets, blurring the line between two distinct categories of celestial bodies and offering yet another puzzle for astronomers to solve. Now turning to the intriguing phenomenon of asteroids mimicking comets, we find ourselves exploring a celestial crossover that continues to baffle scientists. Unlike typical asteroids, which are rocky and lack the icy cores of comets, some asteroids surprise us by displaying comet-like tails. A well-known example of this is the asteroid 3200 Phaethon, which sheds material as it approaches the Sun, creating a dusty tail similar to that of a comet. But what causes this curious behavior? One theory suggests that these asteroids, often referred to as active asteroids or main belt comets, could have small amounts of volatile substances beneath their surfaces. When exposed to the Sun's intense heat, these volatiles vaporize, releasing dust and creating the characteristic tail seen in comets. Another hypothesis points to mechanical processes, such as asteroid collisions or rapid spins, causing surface material to break apart and trail behind. This hybrid behavior challenges the traditional boundaries that separate asteroids and comets, suggesting there may be more fluidity between these categories than we previously assumed. By studying asteroids like 3200 Phaethon, scientists aim to understand how these celestial bodies evolve and interact with their environments over time. This line blurring not only expands our knowledge of space, but also offers hints about the early solar system's conditions and the processes that shaped it. With the next phase of the journey in sight, we now turn to another cosmic enigma: rotational oddities in asteroids that defy expectations and reshape our understanding of their dynamics. Now turning to the fascinating topic of rotational oddities in asteroids, we encounter another mystery that leaves scientists scratching their heads. Unlike the smooth, predictable spinning motions often associated with celestial bodies, some asteroids exhibit chaotic and irregular rotations. Imagine a cosmic object tumbling unpredictably through space rather than rotating steadily around a single axis. Take, for instance, the asteroid known as Tau-Totes, which displays a bizarre, tumbling motion that seems almost random. This peculiar behavior is believed to result from collisions or gravitational interactions with other objects, disrupting the asteroid's spin over time. But it gets even stranger. Some asteroids also experience what is known as the Yarkovsky-O'Keefe-Radzevsky-Paddock effect. This occurs when sunlight heats an asteroid unevenly, causing a gradual shift in its rotation as thermal energy is radiated back into space. This subtle force can lead to changes in the asteroid's spin rate or even flip its rotation entirely over millions of years. The study of these rotational anomalies provides valuable insights into the structural makeup and history of these space rocks. For example, examining how an asteroid's rotation evolves can reveal clues about its internal composition, whether it is a dense, solid mass or a loosely held together collection of rubble. Additionally, understanding these movements helps scientists prepare for potential asteroid deflection missions, as the rotational dynamics of a target asteroid could impact the success of such efforts. As we dive deeper into these peculiarities, it becomes clear that even the simplest motions in space hold complex stories waiting to be unraveled. With this newfound appreciation for these spinning enigmas, let us now shift our focus to another captivating discovery: dust streams emanating from asteroids and their surprising connection to meteor showers on Earth. Now turning to the intriguing phenomenon of dust streams, we uncover yet another astonishing aspect of asteroid behavior. Picture this: tiny particles of dust trailing behind certain asteroids, almost like a faint cosmic tail. These dust streams are not only captivating to observe but also carry immense scientific significance. But how do these streams form? Scientists believe that they originate from the slow erosion of an asteroid's surface, caused by a combination of factors such as solar radiation, micrometeorite impacts, or even past collisions. Over time, these processes release fine particles into space, creating a persistent stream of dust that follows the asteroid along its orbit. What makes these streams even more fascinating is their connection to meteor showers on Earth. When our planet intersects the path of one of these dust trails, the particles burn up in our atmosphere, creating the stunning streaks of light we know as meteors. A perfect example of this is the Geminid meteor shower, which occurs each December. This spectacular display is linked to an asteroid named Phaethon, whose dust stream supplies the material for the annual celestial show. Unlike most meteor showers, which are associated with comets, the Geminids are a rare exception where the source is an asteroid, blurring the lines between different celestial phenomena. Studying these dust streams not only enhances our understanding of asteroid compositions and behavior, but also deepens our appreciation for how such distant objects can create breathtaking events visible right here on Earth. As we unravel the mysteries of these delicate trails in space, it becomes clear that even the smallest particles can spark awe-inspiring wonders. Speaking of wonders, let us now venture into the dramatic histories etched onto asteroids, exploring the evidence of collisional breakups that have shaped these space rocks over billions of years. Now turning to the powerful tales of destruction and creation, we explore the evidence of collisional breakups etched onto the surfaces of asteroids. Imagine two massive celestial bodies hurtling through the vastness of space, their paths crossing in a catastrophic collision. The result of such an event is not just chaos but the birth of entirely new fragments, which we now recognize as asteroid families. These families are clusters of smaller fragments that share similar orbital characteristics, providing a fascinating glimpse into their violent origins. One well-documented example is the Flora family, believed to have been born from a colossal impact over 1 billion years ago. Scientists have traced the orbital paths and compositions of these fragments to piece together the story of their formation. Another remarkable case is the Eunomia family. The fragments in this group are thought to have originated from an enormous collision that shattered their parent body, leaving behind a trail of debris now spread across the asteroid belt. These collisional breakups not only reveal the raw power of the forces shaping our solar system, but also serve as valuable laboratories for studying the evolution of asteroid surfaces and interiors. By examining these fragments through telescopic observations and spacecraft missions, scientists can uncover vital clues about the materials that made up the parent bodies, their internal structures, and even the conditions that existed during the early days of our solar system. What makes this phenomenon even more compelling is how it helps us understand the intricate dance of celestial mechanics, as these fragments continue to orbit the Sun, sometimes crossing paths with Earth and the planets. Studying evidence of collisional breakups is like piecing together a cosmic puzzle, one fragment at a time, giving us a deeper appreciation for the dynamic and ever-changing nature of our celestial neighborhood. With these fragments leading us into the past, we now turn our attention to a perplexing mystery surrounding asteroids that seem to lose material in ways we cannot yet fully explain, uncovering the enigma of missing material. Now turning to the puzzling phenomenon of missing material, we delve into the mysterious cases where asteroids appear to have lost mass that cannot be easily accounted for. Imagine observing a celestial body, expecting it to match its calculated mass based on size and density, only to find a baffling discrepancy. This enigma has led scientists to explore several plausible explanations. One widely accepted theory suggests sublimation, a process where solid material turns directly into gas when exposed to the intense heat of the Sun, causing parts of the asteroid to gradually vanish into space over time. Another possibility points to violent collisions. These impacts could eject fragments of the asteroid into space, creating debris fields we might not initially associate with the original body. But some hypotheses venture into speculative territory, entertaining the idea of alien interference or unknown forces at play that could strip material from these celestial objects. While such theories are often met with skepticism, they highlight just how little we truly understand about the complex forces acting upon asteroids. Beyond the practical implications, this mystery deepens our curiosity about the hidden processes shaping these ancient space rocks. As scientists continue to analyze this missing material through advanced telescopic methods and data from asteroid missions, they hope to unravel what might be one of the most intriguing riddles of our solar system. With this enigma lingering, we now turn our gaze to a compelling transformation: asteroids that blur the line between their rocky nature and the icy tails of comets. Now turning to the astonishing discovery of phosphorus on asteroids, we uncover new clues about the origins of life as we know it. Phosphorus is a crucial element for life, playing a key role in forming DNA and RNA, the molecular blueprints for all living organisms. So, when scientists detected traces of phosphorus on asteroid samples, it ignited a wave of excitement and profound questions about how this essential ingredient may have been delivered to Earth. One groundbreaking study analyzed material collected from an asteroid through space missions and revealed the presence of phosphorus compounds embedded within the rock. These findings suggest that asteroids could have acted as cosmic delivery systems, bringing life-building materials to the early Earth billions of years ago. This stands as yet another piece of evidence in support of the theory that life's building blocks may have had extraterrestrial origins, but there is more to this story. The detection of phosphorus on asteroids also raises broader questions about planetary chemistry in other parts of the solar system. Could these life-essential compounds exist elsewhere, perhaps even on planets or moons that we have yet to fully explore? The implications are staggering, as this discovery not only deepens our understanding of our own origins, but also expands the possibilities for life beyond Earth. With each new discovery, researchers are piecing together the puzzle of how the ingredients for life might be widely distributed throughout the cosmos. As we marvel at the profound implications of finding phosphorus on asteroids, our journey forward takes us to yet another remarkable feature: asteroids with high porosity, revealing structures that resemble cosmic sponges. Now turning to asteroids with high porosity, we encounter space rocks that defy conventional expectations with their sponge-like structures. These asteroids are not the dense, compacted chunks of rock you might imagine, but instead they are surprisingly lightweight and filled with empty spaces. This high porosity means that a significant portion of their volume is void, making them remarkably fragile. Scientists believe this unique composition results from countless collisions over billions of years, shattering and reassembling the asteroid material into loose aggregates rather than solid masses. Understanding these porous structures provides vital insights into asteroid formation, offering clues about the chaotic conditions present in the early solar system. These sponge-like asteroids also pose challenges and opportunities for future space missions. Their delicate nature makes landing and extracting samples more complicated, but it also suggests that they might be resource-rich deposits of metals, water, or other materials locked within their porous interiors. The study of such asteroids not only informs us about their origin, but also helps us understand how they may have played a role in shaping planetary bodies through impacts. As we continue to explore these unusual structures, we are left to wonder how many secrets these cosmic sponges still hold. Moving forward, we delve into an even stranger topic: the mysterious signals some asteroids appear to emit, leaving scientists and enthusiasts alike puzzled and intrigued. Moving forward, we arrive at one of the most enigmatic discoveries yet: mysterious signals emanating from certain asteroids. These signals, detected as faint but unusual bursts of radio waves or electromagnetic anomalies, have left scientists scratching their heads. Could they be the result of natural processes, such as interactions between charged particles and magnetic fields on or around the asteroid? Or are they simply glitches in the detection equipment, misinterpreted as something more extraordinary? The possibilities stretch even further, sparking speculative debates about the potential of extraterrestrial origins. While most scientists approach these signals with caution, attributing them to natural cosmic phenomena, some enthusiasts wonder if these could be attempts at communication from intelligent life. Adding to the intrigue is the fact that these signals often defy clear explanation, standing out from the typical background noise of space. As researchers continue to study these anomalies, they must sift through mountains of data to isolate genuine signals from random interference, making this a painstakingly slow and challenging process. However, the mystery deepens when considering their implications. If these signals are indeed natural, they could reveal new, unknown processes occurring on or near asteroids, expanding our understanding of the cosmos. And if, by some extraordinary chance, they originate from an intelligent source, it would represent one of the most groundbreaking discoveries in human history. For now, the truth remains elusive, leaving room for both scientific investigation and imaginative speculation. As we ponder the origins of these puzzling signals, let us shift our attention to another fascinating subject: asteroids that blur the line between rocks and comets, revealing hybrid characteristics that challenge our conventional classifications. Now turning to the deeper investigation of these mysterious signals, let us explore the scientific theories that attempt to explain their origins. Among the most widely discussed possibilities are natural electromagnetic phenomena. For instance, charged particles from solar winds interacting with an asteroid's metallic surface could create bursts of radio waves, much like how auroras form on planets with magnetic fields. Another hypothesis suggests that these signals might be the result of cosmic rays colliding with certain minerals on the asteroid's surface, producing frequencies that resemble artificial transmissions. These scenarios, while fascinating, point to entirely natural processes that remind us of how much we still have to learn about the intricate dance of particles and energy in the cosmos. On the other hand, the cultural fascination with alien contact often intertwines with such discoveries. Whenever unusual signals are detected, they inevitably spark theories ranging from advanced extraterrestrial technologies to intentional communication attempts. In popular media and folklore, the idea of receiving messages from intelligent beings has long captured human imagination, fueling both excitement and skepticism. Yet most scientists remain grounded, emphasizing that extraordinary claims require extraordinary evidence. Some researchers even caution against jumping to conclusions, as human-made interference from Earth-based technology could easily account for some of these anomalies. For example, satellites, radio transmitters, or even stray signals from deep space probes might mimic the unusual bursts detected near asteroids. However, these signals still present an undeniably intriguing puzzle. Whether natural or otherwise, finding definitive answers could illuminate unknown aspects of cosmic physics or, in the boldest scenario, reveal evidence of life beyond Earth. Either way, the process of uncovering the truth demands rigorous data analysis, innovative technologies, and the collaborative efforts of scientists across the globe. As we delve into the mysteries of the universe, these enigmatic signals remind us of the delicate balance between scientific inquiry and the human desire to imagine what lies beyond the stars. With this in mind, let us journey further into uncharted territory, moving forward to explore asteroids that blur the line between their rocky nature and comet-like behavior, challenging the boundaries of celestial classification. Now turning to the fascinating phenomenon of asteroids mimicking comets, let us delve into these unusual hybrids that challenge the very way we classify celestial bodies. Take, for instance, the asteroid known as 3200 Phaethon, a prime example of this puzzling behavior. Unlike typical asteroids, which are primarily rocky and lack the icy composition of comets, Phaethon exhibits a comet-like tail whenever it approaches the Sun. This tail, however, is not made of vaporized ice as seen in comets, but rather a stream of dust particles. Scientists believe this occurs due to the asteroid's extreme proximity to the Sun during its orbit, where intense solar heat causes its surface to crack and release dust in a process known as thermal fracturing. What makes Phaethon particularly intriguing is its role as the parent body of the Geminid meteor shower, an annual spectacle that lights up Earth's skies every December. This connection further blurs the line between asteroids and comets, as meteor showers are typically associated with the debris trails left by comets, not asteroids. Such hybrids force scientists to rethink the traditional boundaries between these two types of celestial objects. They raise questions about the origins and evolution of asteroids that share comet-like traits. Could these objects represent a transitional phase in the life cycle of small bodies in the solar system? Or do they hint at a more complex history of material exchange and collisions between asteroids and comets over billions of years? These questions are not merely academic, they have profound implications for our understanding of the solar system's formation and dynamics. By studying these hybrids, we learn more about the processes that shape celestial bodies, from their composition to their orbital behaviors. This, in turn, helps us refine our models of planetary systems, both in our cosmic backyard and around distant stars. As we continue to uncover the secrets of asteroid-comet hybrids, we are reminded of the endless diversity of the universe and the many surprises it still holds. With this sense of wonder, let us now explore the mysteries of asteroids that exhibit unusual rotational patterns, revealing even more about the dynamic and unpredictable nature of these rocky travelers. In summary, the 25 bizarre discoveries scientists have made on asteroids illuminate just how mysterious and extraordinary space truly is. From the surprising traces of water molecules hinting at the origins of life, to ancient stardust older than our solar system, and even the puzzling asteroid-comet hybrids that defy classification, these findings challenge everything we thought we knew about the cosmos. Each revelation is a piece of a larger puzzle, a story of creation, evolution, and the interconnectedness of celestial bodies. They remind us that even the smallest rocks in space hold the power to reshape our understanding of the universe. These discoveries not only deepen our knowledge but also ignite a sense of wonder and curiosity that drives humanity to explore further. Which of these discoveries fascinated you the most? Let us know your thoughts in the comments below. If you enjoyed this journey through the mysteries of the cosmos, be sure to like this video, subscribe to our channel, and hit the notification bell so you never miss a chance to uncover more incredible space mysteries with us. The universe is vast and its secrets are calling. Let's continue exploring together.